All right, so these notes are going to teach you how we look at graphing in physical science and how we organize a data table and then transfer data from that data table onto a graph. So first of all, why do we make graphs? Graphs are a good way to visualize data and see patterns or trends or some pieces of data that don't fit those patterns or trends. They're inconsistent, or we call them outliers. Different types of graphs allow us to see different types of data. And so bar graphs allow us to compare qualitative independent variables like the type of candy or the species of bear. And then line graphs allow us to compare quantitative or like numerical independent variables like time. So seconds or hours or years, and then some other type of number like a height or a quantity. In physical science, we are only going to make the second type of graph, which is a line graph. We're never going to make bar graphs. To make a data table, which will then ultimately become a graph, we have to organize them in a specific way. And if we organize them the same way every time, then it will be very predictable when we try to make it into a graph. So it's a good idea to set up a data table before you do an experiment. That way, when you're finding results in an experiment, you can enter them into the data table if it's set up correctly. And it kind of helps you know what the next step is in your experiment. When you are making a data table, there are a couple of tips to follow. The independent variable is on the first column or the left side of the data table. You should put multiple trials and times to the right of that. And then units shouldn't be in every single cell. And so I'll show you what that looks like on the next slide. So this data table is set up really nicely. Temperature is the independent variable over here. It's on the left side. And then the different trials of speed are over here. Once we start to fill out this data table, if we were to measure 45 seconds or 30 seconds, we wouldn't put the unit seconds in each one of these cells because that would make all of these cells very, very crowded and cluttered. So instead, we're just going to put that unit at the top of the table, and that tells us that any number in here is a second or is measured in seconds. Any number in here is measured in degrees Fahrenheit. So there are some links between graphs and data tables. Independent variables go on the left side of the data table and the bottom of the graph, okay? And then dependent variables go on the right side of the data table or up the left side of the graph. And then an outlier is a piece of data that doesn't fit the trend of the rest of the data. When you make a graph, you can use this acronym TAIL in order to make sure that you remember all of these details and parts of a graph that aren't necessarily just the visualization of the data, but they help us to visualize the data. So the first thing we want to make sure we do is we put a title on our graph, and there's two different formats that are widely used. The effect of the independent variable on the dependent variable, or the effect of the bottom axis on the left axis, or just the independent variable versus the dependent variable. Next, we want to make sure that we're putting the right variables on each axis. And so we're making sure that we put one on the bottom or the x-axis and one on the side of the y-axis. After we decide where the data is going to go on the axes, then we need to make sure that the intervals are measured out in a way that will help us to visualize all the data. So we want to make sure that each interval for the spacing between the lines on the graph is the same. It doesn't change size. And we want to make sure that the range is good so that we can fit all of our data on the table. And then the last thing is that we want to label each axis with a unit in addition to just the name of the variable. So before we said we'd put temperature on one axis and speed on the other axis, we also want to say what unit is that temperature measured in and what unit is the speed measured in. Then this doesn't apply to all graphs, but some graphs have keys because they have different types of colors or shapes to show different data sets on the same graph. And so then a key would be a good thing to remember as well. In order to make those intervals the right way, we have this 5-step process, which you apply to each axis separately. So you look at just the x-axis for the independent variable, you do this whole process, and then you repeat this whole process on the left side for the dependent variable after that. Instead of reading all of these different steps to you, I'm going to do an example so that you can see that happen in action. So here we've got an example of a data table. On the left side of our data table, we've got the independent variable. So the independent variable is the annual average temperature. And then on the right side, we have the dependent variable, which is the average annual snowfall. So if we follow through all of our different steps, the first thing that we need to do is write a title on our graph. And the title is going to be the effect of the independent variable right here, which the independent variable is annual average temperature. On the dependent variable, which is average annual snowfall. So we got the title out of the way. The next thing that we're going to do is look at the axes. And the axes are making sure that the independent variable goes on the x-axis or the bottom. So on the independent variable, or on the bottom of the graph, we're going to write down annual average temperature. And then on the side, we're going to write down the dependent variable on the y-axis. So the y-axis is along the side of the graph right here. We're going to write down average annual snowfall. And then we get to the part where we need to look at our intervals. So for our intervals, that's where we're going to start to look at this checklist down here. And so when we're looking at the intervals on the x-axis down here, then what we need to do is only look at this data for locating the highest number and counting the spaces and so forth. So first I'm going to do this for the independent variable, then we'll repeat it for the dependent variable. The highest number in the independent variable, the highest temperature, is 25 degrees Celsius. Then we have to count the number of spaces available. So we're only looking at the bottom of the graph here, and the number of spaces are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 spaces available on the bottom of our graph. And then what we're going to do is we're going to divide the highest number by the number of spaces. So for this, we're going to take 25 divided by 10, and then round that answer up to the nearest number that we can count by. So 25 divided by 10 is 2.5. And counting up by 2.5s might be a little bit complex, but if we round 2.5 up, we can round it to 3, and then I know that if we count up by 3s, we can go from 0 to 3 to 6 to 9 and so forth. Then what we're going to do is we're going to start labeling at 0, and that's going to be right on the corner. And then we're going to label every single line going up by this number that we found in the fourth step. So 3, 6, 9, 12, 15, 18, 21. Zoom in real quick. 24, 27, and 30. Then we're going to repeat this entire process with the dependent variable, okay? And so we're just going to look at these numbers and we're going to re-answer all of these questions in order to see what we have to do for the dependent variable. So by looking at just the dependent variable side of the table, I found that our largest number is 2. I counted the spaces along the side and found that there were 10 spaces. I divided them and got 0.02, and then, I got 0.2. And when I considered this fourth step about rounding the answer up, if I rounded this up to like 1 or 0.5, then I would waste a lot of space on this graph because I would get much farther than 2.0 by the end of the graph up here. And so what I decided to do was not round it, because counting by 0.2s kind of reminds me of counting by just 2. So instead of going 2, 4, 6, it was 0.2, 0.4, and 0.6. And so that's how I numbered the axis. If you look here, starting at 0 at the bottom, and then going up to 0.2, 0.4, 0.6, all the way up to 2.0. So now that our intervals are labeled, we have to make sure that we label each axis with the unit. And so I labeled the axes at the beginning, but I did not put the units on the independent variable, which is on the bottom. The average annual temperature is measured in degrees Celsius. So I'm going to add that right to the end here. Degrees Celsius. And then for the dependent variable, the amount of snowfall is measured in meters. So I'm going to add that to this label as well. And now we have the graph set up, so it's ready to actually graph some data onto it. So now to graph the data, what we're going to do is we're going to look at the first number of 0 and find that on the independent variable side on the bottom. So it's right here. And then we're going to make sure it goes all the way up to where it crosses the dependent variable at 2. And so the first data point is right here at the intersection of 0 temperature and 2 meters of snowfall. Then the next one is at 5. 5 is going to be between 3 and 6, but closer to 6. And that's going to go all the way up to the 1.2. So you'll notice that I made a small mark down here and then followed it up until I hit the right level on the dependent variable side. Our next one is at 10, which will be between 9 and 12, but closer to 9. That is at 0.8 meters of snowfall. The next will be at 15. 15 is luckily shown on our axis, so we can follow that line up to 0.2. 20 is between 18 and 21, but closer to 21. That will be right between 0 and 0.2. And then at 25, the snowfall is 0. So I'll get these helper marks out of there. And this graph now shows what the final graph should look like. Making sure that we put a title, axes were labeled, the intervals were counted out the right way. And then we labeled everything before we started plotting data points. So you could take a couple of minutes, you could pause this video and try to graph this data. There should be room on your notes. And then once you are done, you can unpause your video and see the answer, which I'll show you in just a moment. Beware that because there are 3 different trials, it would be good to use 3 different colors of pen or pencil. Or if you don't have 3 different colors, then what you can do is use different shapes. So for example, on this one, I used dots for the first data set. If I had another data set on here, what I could do is I could make triangles for the other data set. And so those data points would look something like that. Or you could make squares or open circles. So just making sure that if someone was looking, they would see the difference between different data points that belong to different trials or series. So at this point, you should pause your video, try to graph this, and then unpause it to check. So here is the answer. We've got a title. The axes show that the speed of reaction is on the dependent variable side. The temperature is on the independent variable side or on the bottom. So the temperature is down here and the speed of reaction is on the side. They looked at the largest data point for temperature and then divided that by 10 spaces and rounded it up to go by intervals of 10. So each line is 10 away from the last line. We looked at the largest amount of seconds for the dependent variable, and we found that that was 40. So we took 40 and divided by 10, because again, there's 10 spaces here, and we got that each space should go up by 4. And then we plotted the data points. You'll see over here is a key, and this key has black circles, black squares, and blue circles, so that you can see that this data is different than this data is different than that data, because those are all different trials. So at this point, you should be able to successfully attempt worksheet 2.